Welcome to my presentation, and the purpose of this presentation, I want to show how you can prove algebraic expressions using the normal concepts starting from the area of a square. Because most of these expressions, for example, look at this expression, a minus b in bracket squared, b equal to a squared minus 2ba plus b squared. It looks abstract, but when you are told to prove it, you may think so many things. But when you use simple logic, use the square from the known knowledge to the unknown, you can get there. So our main intention here is to prove a minus b squared equal to a squared minus 2ab plus b squared. So take an instance, assuming that this is our square. We have a square is a polygon with all equal sides. We are assuming that from this point to that point is a, and from this point to this point is a. And from our knowledge of figures, we know that area of any shape is length times width. So if we take this to be our length, and this is our width, therefore our area will be a times a, and we shall have a squared. So what if this, remember our original square was in green, this is the original square. But what if we just reduce it, resizing it, by reducing it by distance or by length b? So if I reduce it from here to here by b, there's something I'm going to do from here to here, which is that. Initially, my length from this point to that point was a, but when I remove off b, the remaining length will be a minus b. Same applies here. From here to here it was a, but if I take off this part, I'll remain with a minus b. So the area of the remaining green square will be this length times this width, which will be a minus b in the brackets, that's our length, times the width, which is a minus b. And will give us a minus b squared. But I'm also interested in knowing these other parts which I've cut off. If I'm interested in knowing the area of the parts I've cut off. Remember from this, let me start with this. This length from here to here is b, but this did not change. It is still a. Therefore, the area of this blue part is going to be length times width, which will be b times a, or a times b. Then same applies to this. From this point to that point is the same as from here to that. Therefore, my length from here to here is a minus b, and my width is from here to here, which is b, and my area will be b times a minus b. So a1 was the area of the original shape, which we had. A2 is the area of the new square we got. A3 is the area of this smaller part we got, which is a rectangle. And A4 is another area of a second rectangle. Now, in order to get the area A2, in terms of the original square we had, and these other two figures, we shall say, A2, the area of the remaining square, the same as getting the area of the original square we had, minus the area of this other rectangle, minus the area of this other rectangle we have. Remember, area A1, which was a times a, which was a squared. Area A3, it is b times a, which is this. Area A4 is b times ab times b, which we have ba minus b squared. So when you open up our brackets, I have a squared, have a minus b, also have a minus b. These two parameters are the same, that's why they give me 2ab or 2ba. Then this negative times the negative will give me ab squared. So the sum of this gives us that. But we also realize that when you used a minus b times a minus b, our answer was a minus b squared, and we have also found that to be this. Hence the proof. So thank you. We can use this same knowledge to prove the difference of two squares. We can use to prove several other algebraic identities using the same concept of area of squares or area of polygons.